Department of Collegiate and Technical Education welcomes you for Learning and Management System program, first year BE, common to all, course Engineering Physics, course code 18 PHY 12 bar 22, module 4, laser spot, session 1, learning outcomes. At the end of this session, students are able to understand a brief introduction to laser, applications of laser, types of interaction of light with matter, and finally possible questions. One can see here lasers with different colors. This is semiconductor laser with purple color, blue and red color. Introduction to laser. The laser was first built in 1960 by Theodore H. Myman, and the acronym goes like this. The laser stands for light amplified by stimulated emissions of radiation, and the definition goes like this. The laser is an optical device which produces a beam of light with the following characters, which are highly monochrome, highly narrow, highly coherence, sharply focusing, and finally highly intense. One can see here the difference between laser light and ordinary light. First one, the laser is highly monochromatic. One can see here the laser is emitted only green colored light, whereas the ordinary light emitted all possible colors. Second one, the laser is highly directional. It moves only in single direction. Therefore, we call it as highly directional, whereas the ordinary light spread light in all possible direction. That means there is a angular divergence in all possible direction. Third one, coherent. The light waves maintain constant phase difference, that is crust and trough, crust and trough of all the waves meet at common point or same point, whereas the light waves from the ordinary source will not maintain any constant phase difference. Therefore, these light waves are out of phase. And fourth one is sharply focusing. That means you can see the diameter of the laser spot is very narrow, whereas the diameter of the ordinary light spot is very large. That means there is an angular divergence, whereas in the laser source there is no angular divergence. In the case of ordinary light, one can see angular divergence, therefore it is not sharply focusing. Whereas finally, the laser is highly intense because the laser emitted by amplified by stimulated emission. The intensity of the laser is very high, that is the photon density is very high, whereas the ordinary light there is no much intensity. Applications of laser. Due to the above remarkable properties, lasers found a wide range of applications. For instance, few of them are mentioned here. First one, in the field of medicine and healthcare, bloodless surgery, ophthalmology, dentistry, tissue repairs, kidney stone treatments, etc. In the field of defense, and security, marking targets and missiles, etc. In the field of scientific research and enforcement, they are used in forensic sciences, fingerprint detection, spectroscopy, etc. In the field of commercial and entertainment, which are laser printers, barcode scanners, 3D holograms, laser light shows, decorative purposes, optical disc readers, optic fiber communication, etc. One can see the various applications of lasers here: barcode reader, dentistry, missiles or marking targets, fingerprint detection, laser printers, optic fiber communication, and decorative purposes. Interaction of light with matter. As we know, the laser action is the consequence of interacting light with contents of a matter. It's a process in which the exchange of energy will takes place between the light photons and the contents of a matter. There are three types of interaction of light with matter is there, which are induced absorption, spontaneous emission, and stimulated emission. We'll discuss one by one. First we go for induced absorption. It is the optical phenomenon in which the atom promotes from the lower energy to higher energy level by absorbing a suitable energy from the incident photon. Here, one can indicate mathematical equation like this. The atom is initially in ground state or lower energy state and receiving energy from external photon, that is h nu. Consequently, the atom gets excited. Here, one can observe the atom is initially in ground state. When the photon is interacting with atom, the atom receives suitable energy or necessary energy to promote for higher energy level, provided the energy of incident photon must be greater than or equal to energy gap between E2 and E1. Remember, energy gap is nothing but amount of energy needed to lift the electron from lower energy level to higher energy level. For example, if the energy gap between two energy level is 3 electron volt means the energy of the incident photon must be equal to or greater than 3 electron volt. If the energy of incident photon is less than 3 electron volt, the atom will not excite. If the energy of the photon is more than 3 electron volt, the atom will excite. The extra energy may be utilized for kinetic energy of the atom. Second interaction, spontaneous emission. The excited atom falls back to the lower energy level on its own by emitting a photon. Mathematically, one can mention here the excited atom decays to ground state on its own with the emission of photon with the energy h nu. The energy of photon is equal to energy gap between lower and higher energy level. Here, it is spontaneous emission. That means the atom does not require any external energy for its decay. Remember, all the excited atoms will not spend more time in the higher energy level, so it spends only about 10 to the power of minus 9 second, since the atoms in higher energy level are or excited levels are highly unstable. Therefore, it returns to the ground state with the emission of photon with the energy equal to energy gap between higher and lower energy level. Remember, the photon which is emitted in spontaneous emission is strongly direction independent. It can move in any direction. Examples for spontaneous emission: LED, incandescent bulb, sunlight, mercury vapor lamp, sodium vapor lamp, etc. These are all examples for spontaneous emissions. Finally, the stimulated emission. In this case, the excited atom fall back into the lower energy level with the assistance of another photon of bright energy by emitting two identical photons. Here, the excited atom interacts with another photon, therefore, the atom decays to ground state with the emission of two identical photons. Here, the identical photon means the photons will have same energy, same direction, moves with same speed, and maintains constant phase difference. Therefore, these two photons are also called as coherent photons. And also, the photons are strongly direction dependent. Therefore, this is what we call coherent photon. Whereas in the case of spontaneous emission, the photon which is emitted is incoherent, while the photons are emitted from stimulated emission is strongly direction dependent and maintain constant phase difference. Therefore, we call it as coherent photons. And finally, possible questions. What are the types of interaction of light with matter? As we discussed, it is stimulated absorption, spontaneous emission, and stimulated emissions. Define stimulated absorption. As we mentioned in the previous slide, the atom, initially in the ground state, absorbs energy from the external photon and promotes to higher energy level. Here, the energy of photon absorbs, therefore, we call it as stimulated absorption. And spontaneous emission. The excited atom falls back to ground state without any assistance by emitting photon with energy equal to energy gap between higher and lower energy levels. What is the condition for stimulated emission? Condition for stimulated emission are the atom must be initially in excited state, and also the photon should interact with atom present in excited level. Does spontaneous emission depend on external agency? No, it won't depend on energy of external agency since it is voluntary emission. Mention the difference between the spontaneous and stimulated emissions. The first difference is the atom does not require external agency for its decay in spontaneous, whereas in stimulated emission, which require external energy. In spontaneous emission, one photon will be emitted. In stimulated, two identical photons emitted. In spontaneous, the photon direction independent and incoherent, whereas in stimulated emission, direction dependent, whereas coherent. Why the two identical photons are emitted during the stimulated emission. The one photon, which is the consequence of the photon absorbed during excitation, and another photon due to the photon interacted with excited atom. Recall the applications of laser. One can observe in the above slides what are the properties of laser. The properties of lasers are monochromatic because the atoms decay from same energy level. Therefore, we call it as monochromatic, and highly directional because the laser is due to stimulated emission, therefore maintains highly directional, and also highly coherent because the atoms emitted from same instant of time from same energy level, and sharply focusing due to highly directional nature, it maintain highly focusing ability. And last one is highly intense due to the laser is amplified output. These are the references. These are the content developers. Thank you.